Some addition polymers. Addition polymers are obtained by the repeated addition of monomer units, and these are obtained from different unsaturated compounds like alkenes, alkynes and their derivatives. And these addition polymers are categorized into 4 groups. First one is polyolefins. Polyolefins are polymers derived from olefins. Example, polythene, polypropylene, then polystyrene, etc. Second category is polydienes. Polydienes are polymers derived from dienes. Example, synthetic rubbers like neoprene, BUNA, then BUNA, etc. are examples. Third category is polyhaloolefins. Polyhaloolefins. These are polymers derived from halo-substituted alkenes. Halo-substituted alkenes. Example, polyvinyl chloride. Polyvinyl chloride or PVC. Then polytetrafluoroethylene or Teflon. These are some examples. Okay. Now, fourth category is polyacrylates. Polyacrylates are polymers derived from acrylic acid. Acrylic acid group is this one, CH2 double bond CH3. This is acrylic acid. Those derived from their derivatives are called as polyacrylates. Example, methyl-methacrylate. One example, PMMA. It's also called as PMMA. Another example is polyacrylonitrile. Another example, also called as PAN. PAN. These are the 4 categories of addition polymers. Let us discuss some important polymers. Okay. First one is polythene. Polythene, there are 2 types of polythene. First one, low density polythene or LDPE. Second one is high density polythene or HDPE. First, let us discuss about LDPE. First, preparation. This is obtained from the polymerization of ethene under high pressure, high temperature and the presence of catalyst. How can we prepare LDPE? First, ethene polymerizes at a pressure of 1000 to 2000 atmospheric pressure and at high temperature, that is 350 to 570 Kelvin. The reaction takes place. Okay. And the catalyst used is traces of dioxygen, or we are using a peroxide catalyst. Peroxide or traces of dioxygen is used as catalyst. Okay, this is the catalyst used. So reaction takes place and LDP, this bond breaks and get polymerized and form LDP. Okay. Their important properties are they are highly branched structure and they are chemically inert. Okay, and they have low density. They have low density and they are poor conductor of electricity. Poor conductor. Next, their important uses. Due to its low conductor of electricity, it can be used as insulation of electric wires. Insulation of electric wires. Okay. Used as insulation of electric wires. Another use is it is used for the manufacture of squeeze bottles, toys, squeeze bottles. Then toys, flexible pipes, etc. Second polyethylene is HDP. Second one, HDP or high density polyethylene. How can we prepare this? This can be prepared from ethene at a temperature of 333 to 343 Kelvin and an atmospheric pressure of 6 to 7 atmospheric pressure. And the catalyst used here is Ziegler-Natta catalyst. Ziegler-Natta catalyst. Ziegler-Natta catalyst. Ziegler-Natta catalyst is triethyl C2H5 thrice. That is triethyl aluminium and titanium chloride, tetrachloride, titanium tetrachloride. This is called as Ziegler-Natta catalyst, and this catalyst is used in the case of high density polyethylene, for the preparation of high density polyethylene. Okay, and at a temperature and pressure, the reaction takes place and it gets polymerized. This bond breaks and form HDP. This is HDP. Okay, and their important properties. They are linear molecules and they are high density. They have high density. That is why they are called as high density polyethylene. Due to their close packing, they are having high density. They are chemically inert. They are tough and hard. Okay, and so they are used for making buckets, manufacturing buckets. Then another use is used for making dustbins. Then bottles, pipes, etc. These are the important uses of HDP. Next, second one is polystyrene. Polystyrene or styrene is also called as styrene. How can we obtain this? This can be obtained by the polymerization of styrene on heating in presence of a catalyst, benzoyl peroxide. See the reaction. Styrene. This compound is called as styrene on heating in presence of benzoyl peroxide catalyst. What will happen? This bond breaks and form CH, CH2, C6H5 in times. This compound is called as polystyrene. Now, what are the properties? They are transparent polymers. So, they are used for making uses. Combs, toys, then hot drink bottles. hot drink cups. Then household articles, etc. can be made. Okay. Now, third one is Bunas. 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 Okay. Styrene, butadiene rubber. This is a copolymer because this is obtained by the copolymerization of styrene and butadiene. See the reaction in the ratio 1:3. Butadiene is this one. Butadiene. 1,3 butadiene. Okay, this is 1,3 butadiene. On reaction with styrene. Copolymerizes, and here we are using sodium, metallic sodium as catalyst. So it got its names Bunas. Bu means butadiene, Na means sodium, S means styrene. So it got its name Bunas and polymerizes and form Bunas. CH2, this bond breaks and shifts towards here. Then CH2, then CH, CH2, C6H by this ring. Okay, N times. This is Bunas. Okay, Bunas. And its properties are they are rigid, extremely resistant to wear and tear. Okay, so they are superior to natural rubber. They are superior to natural rubber. So they are used for making automobile tires. Uses automobile tires. Then another use, it can be used for making floor tiles, cables, insulation, etc. Floor tiles, cables, insulation, etc. are the uses of Bunas. Okay. Next, fourth compound is polyvinyl chloride or PVC. Polyvinyl chloride or PVC. This can be obtained by the polymerization of vinyl chloride in the presence of catalyst benzoyl peroxide. See the reaction. CH2 double bond CH Cl. This is vinyl chloride. In presence of benzoyl peroxide, polymerizes CH, Cl, CH2 N times. This is called as PVC. PVC can be obtained like this. Then its uses. It can be used for making raincoats. Uses. Used for making raincoats. Then handbags, hose pipes. Then vinyl floorings. Then curtain clothes, electrical insulations, etc. Electrical insulations, etc. are the uses. Next, fifth one is Teflon or polytetrafluoroethane. Polytetrafluoroethane or Teflon. How can we obtain this? Teflon can be obtained from the polymerization of tetrafluoroethene, CF2 double bond CF2, and in the presence of a peroxide, in presence of acetyl peroxide or ammonium peroxosulfate. Ammonium peroxosulfate, that is NH4. This is ammonium peroxosulfate. In the presence of this or acetyl peroxide, reaction takes place. Any of these catalysts can be used. It gets polymerized and the reaction takes place at a very high pressure. Okay, and the Teflon will be obtained. See the reaction, CF2 double bond CF2. In the presence of any of these catalysts at high pressure. Okay, product will be like this, CF2 n times. This is Teflon. Okay, Teflon. Their important properties. They are inert and resistant to heat and chemicals. They are resistant to heat and chemicals. This property is very useful for making this non-sticky coated utensils. Uses. It's used for making non-sticky coated utensils. That non-sticky thing is Teflon. Okay, coated utensils. Okay, at a temperature of about 300, above 300 degrees Celsius, they decomposes. Okay, so they are used for making non-sticky coated utensils and used for making oil seals and gaskets. These are the important uses of Teflon. Sixth one is polyacrylonitrile or PAN. How can we obtain this? This can be obtained by the polymerization of acrylonitrile. Or it's also called as vinyl cyanide in the presence of peroxide catalyst. See the reaction, NCH2 Cn. In presence of peroxide catalyst, polymerization takes place and the product will be like this, CH, Cn, n times. This is called as PAN. This is acrylonitrile. Polymerizes and form PAN, polyacrylonitrile. This is very hard and high melting point. So, it is also known as acrylan or Orlon. Acrylan or Orlon. Then, its important uses. It is used as a substitute for wool in making commercial fibers as Orlon. Used as a substitute for wool. Commercially it is called as Orlon. Okay. Now another use, used for making carpets, blankets, etc. And they are good resistant to stains. So they are also used for good resistance to stains, chemicals, insects, fungi, etc. Okay. Good resistance to stains, then chemicals, resistance to chemicals, insects, fungi, etc. Fungi, etc. are the important uses of PAN.